Now we're going to apply this idea of continuity to help us solve more complex quadratic or rational inequalities. So our theorem here, we need to start off with, it says if f of x is continuous and never zero on AB, on some interval AB, then either it's always positive on that interval or always negative on that interval. And if you draw it out, I think that makes sense. So it's never zero, so if it's zero, that means it's on the x-axis. So essentially, we're saying you're not allowed to cross the x-axis. And it's continuous, which means that there are no holes, there are no jumps, there are no breaks, there are no asymptotes. So if my function starts right here, let's say, and I'm not allowed to cross the x-axis, I'm not allowed to make any jumps, I have to stay above the x-axis over that interval. So my function might look something like that. It's always positive. Or if I had started below the x-axis, if I had started down here, and again, I'm not allowed to cross the x-axis, I have to stay below the x-axis. So it might look something like that, in which case it's always negative. So it's either always positive or always negative on these intervals. We also need a definition here. So we say that x is a partition number for a function f if either f of x is discontinuous at x or f of x is equal to 0. So if your function is either has a discontinuity at that point or the function is equal to 0, that's going to be what we call a partition number. So I'm going to use these two ideas together to help me solve quadratic and rational inequalities. So I'm going to try and walk through these process here. I'm going to handle these steps as I go, because right now a lot of this won't really mean anything. So we're just going to jump right into an example. We want to solve x squared minus 2x minus 8, and for the purposes of this problem, I'm going to call that my function f of x here. So step 1 says I want to find all partition numbers of f. And remember, partition numbers, if we need to go back and look, it's places where your function is either discontinuous or equal to 0. I'm going to start with equal to 0 here because I think that's a little bit easier for us to manage. So I'm going to take my function x squared minus 2x minus 8, set it equal to 0. We'll solve this inequality. This equality here. So let's see, I need two numbers that multiply to be negative 8, add to be negative 2. That would be x minus 4 times x plus 2. Set that equal to 0. I can take each factor, set it equal to 0. That will give me x equals positive 4 and x equals negative 2. So these are two partition numbers. But it may not be all of the partition numbers I have, because I also need to think about where is f of x discontinuous. Well, in this case, it's really nice because the function we're working with here, our function f of x, this guy right here, that's a polynomial. It's continuous everywhere, so I don't need to worry about it. So that means that x equals 4 and x equals negative 2, these are our two partition numbers. So that's all I'm looking for in step 1. In the next example, we'll look at, okay, what happens if our function does have a discontinuity? What does that look like then? Step number 2, let me do that in a different color here. Step number 2 says we want to plot the partitions on a number line. So I'm just going to construct a number line here, and I'm going to put negative 2 and 4, my two partition numbers on here. And maybe I'll just note over here that I'm talking about the function f of x. But that's really all I need to do in step 2. We're gonna come back to this later on in the next section, or in the next steps, excuse me. Step number 3, I'm going to choose a test number in each interval we created in step 2 and evaluate f at that test number. So I'm going to stop right there and just talk about what that means for a second. I've really created 3 different intervals here. I've created, with these partition numbers, I've created an interval to the left of negative 2. I've created an interval between negative 2 and positive 4. And then I've created another interval to the right of 4. So what I'm going to do is I'm going to choose a test number in each one of these intervals. Now, the test number I pick might be different than the test number that you pick, and that's okay. I want to take that number and plug that into my function. So let's just start with this to the left of -2. So I might pick, how about x equals -3. I'm going to take x equals -3, and I'm going to do this over here. I'm going to plug that into my function. So if x is equal to -3, then I'm working with -3 squared minus 2 times -3 minus 8. So let's see, I've got 9 plus 6 minus 8. Let's see, 9 plus 6, I've got 15 minus 8. That should give me a positive 7 here. So, okay, positive 7. The thing I'm really interested in says note whether f is positive or negative. I really care about the sign here. So, 3 and 4, steps 3 and 4 I'm sort of going to do together here. I know that I ended up with a positive number here, right? A positive number. So over that interval where I just picked x equals -3 from, I'm going to put a plus sign here to remind myself that, hey, we ended up with a positive number. And this is going to be the sign chart that I'm working with. So this is kind of steps 2 and 4 together. So now I'm going to pick a number between -2 and +4. I always like to choose x equals 0, my personal favorite number. So I'm going to take x equals 0. Again, I'm going to plug that into my function. So for x equals 0, I have 0 squared minus 2 times 0 minus 8. 0 minus 0, minus 8 is equal to -8. Again, I really care about the sign. It's negative there. So I'm going to put a minus sign over that interval to remind myself that, okay, that number, that test number that I came up with was negative. And then I need a number to the right of 4. So over this interval here, I might take x equals 5. And I'm going to plug that into my function. So x equals 5. Let's see, I've got 5 squared minus 2 times 5 minus 8. 25 minus 10 minus 8. So 25 minus 10 would be 15. Minus 8, that should give me 7 once again. So again, a positive 7, so a plus sign. So I'm going to put a plus sign over that interval. So at this point, most of the work of this problem is done. I really just need to interpret this sign chart here and use it to help me solve the inequality. So when I interpret this sign chart, I'm going to look back at my original inequality right here. And the thing I want to pay attention to is, what is our inequality saying? Our inequality is saying f of x is greater than 0. So f of x is greater than 0. Well, what kinds of numbers are greater than 0? Are those positive numbers or are those negative numbers? Well, those are negative numbers. So we're talking about negative numbers here. Oops. We're talking about negative numbers here, positive numbers here. So we want to show, or we want to identify the intervals where we ended up with positive numbers. And because I've looked at this sign chart right here, I've created this sign chart, it's really easy for me to say, okay, to the left of -2, we had positive values, and to the right of 4, we had positive values. So the solutions to this inequality would be anything that falls in those intervals. So my solutions here would be this interval right here. Whoops. This interval right here. So -infinity to -2. And then this interval over here, union 4 to positive infinity. Those are my solutions. It's anywhere that satisfies the inequality. If I had changed this, if I had said less than 0 instead, then I would be looking for the negative intervals as, for my solution. So it really just depends on the sign or the direction of that inequality. So let's look at one more. This one's going to be a little bit more complicated, but we'll get through it here. We want to solve, here we have a rational function, x squared minus 1 over x minus 3 is less than or equal to 0. So I'm going to start by finding my partition numbers. So first I might say, okay, let's find where this function is equal to 0. X squared minus 1 over x minus 3 is equal to 0. Now I can't solve this equation with x minus 3 in the denominator, so maybe I'll multiply both sides by x minus 3. On the left-hand side, those two cancel, and I'm left with x squared minus 1. On the right-hand side, 0 times x minus 3, that's just 0. From here, this is something that can be factored, or you can use square roots. If you wanted to, you could use a quadratic formula. I don't know why you would, but you could. I'll use square roots here. X squared equals 1. I take the square root of either side. I end up with x equals plus or minus 1 here. So I actually have two partition numbers here, both positive 1 and negative 1. So here's two of my partition numbers. But now I also need to consider, okay, what type of function do we have here? Well, this is a rational function. This is a rational function. Where is this function discontinuous? It's discontinuous if that denominator is equal to 0. So I'm also going to take my denominator of x minus 3, set it equal to 0, and solve. So this one's a little bit easier to solve. Here I have x equals 3. If you're working with a rational function, that you can kind of take the shortcut of saying, okay, I'm going to just look at where is the numerator equal to 0 and where is the denominator equal to 0. That's kind of one trick you can use here. But I have three partition numbers this time. I have plus or minus 1, and I have 3. So okay, I've got my partition numbers. Let's go and construct our number line here. So let's make our number line. Remember, this is kind of steps 2 and 4. We have negative 1, we have positive 1, and we have 3 here. So now I have 1, 2, 3, 4 intervals. I've got this interval between, to the left of negative 1. I've got this interval between negative 1 and positive 1. I've got an interval between 1 and 3, and then I have an interval to the right of 3. So I'm going to take a number in each one of these intervals, plug them into my function, and then determine, is my function positive or is it negative there? So let's start here to the left of negative 1. Maybe I'll think about, how about x equals negative 2? I'm going to take that and plug it into my function. So negative 2 squared minus 1 over negative 2 minus 3. My numerator, I have 4 minus 1 over negative 5 gives me 3 over negative 5. That's a negative number. So my function must be negative over that interval. Between negative 1 and positive 1 here, how about we choose x equals 0? So I'm going to take that and plug this in. Let's see, 0 squared minus 1 over 0 minus 3 gives me negative 1 over negative 3. That's really positive 1/3. So my function is positive right there between negative 1 and positive 1. Next, I need a number between 1 and 3. X equals 2 is probably the easiest to work with. So let's see, I have 2 squared minus 1 all over 2 minus 3. So let's see, I've got 4 minus 1 all over negative 1 gives me 3 over negative 1 is negative 3. So my function is negative between positive 1 and positive 3. And then I need a number over here to the right of 3. So how about x equals 4? Plug that into my function. 4 squared minus 1 all over 4 minus 3. 4 squared, I've got 16 minus 1 over 1. It's 15 over 1, which is just 15, so it must be positive on that interval. So now, okay, we've done actually most of the work here. I just now need to look at, well, what is the direction of my inequality? Here we're talking about less than or equal to 0, and here I do have to add one caveat here. It says less than or equal to 0, and I need to remember where I came up with these partition numbers, because that's actually going to be really important. It's going to determine whether these numbers are solutions or not. So where did I come up with x equals plus or minus 1? We came up with those by setting our function equal to 0. We came up with those by setting our function equal to 0. So I'm going to just make a note to myself that my function is equal to 0 at -1 and positive 1. At 3, though, this one's tricky. At 3, if you look at 3, we found that by figuring out where our function was discontinuous. And if you wanted to look at 3 here, if you weren't sure, you can always take that number and plug it in. 3 squared minus 1 over 3 minus 3. This is 9 minus 1 over 0, or 8 over 0, which that value is undefined. Undefined or does not exist. So I'm going to make a little note to myself over here that my function does not exist at 3. Because at the end of this, so first of all, let's determine, do I want the positive intervals or the negative intervals first? Well, I want less than or equal to 0, so now I'm talking about negative numbers. I'm talking about this interval right here to the left of -1. And I'm talking about this interval right here between 1 and 3. But what makes this problem a little bit different than the last problem we looked at is this or equal to part right here, that or equal to, which means that if a number makes my function equal to 0, I want to include that. I want that to be part of my solution set, which means I want to include that in my interval. So the way I'm going to look at that is I'm going to say, okay, well, what was the behavior of my function at these endpoints? That's really what I want to know. So at -1, we said, hey, our function was equal to 0, so that means that -1 is included in my solution. So if I want to talk about just this area right here, I would say to the left of -1, so that would be -infinity to -1. We always use parentheses around -infinity, but we want to say that -1 is included because we had the 0 right here. So the way I'm going to do that is I'm going to use a bracket around -1. So that's my first interval. My second then, okay, I said everywhere between 1 and 3, so I know it's going to be 1 to 3. I just need to determine now, do I include those endpoints? So at 1, we said, hey, the function was equal to 0. That's how we found that partition number. So that means that 1 is going to be included. And actually, let me do that before I forget. 1 is going to be included. However, what's the value of our function at 3? At 3, our function is undefined. We said our function does not exist there. And having a function not exist is different than having a function take on a value of 0. So what that means for us is 3 is not included in our solution set, which means that we are going to use parentheses around 3 to show that, hey, 3 is not a part of my solution set. If you take 3, plug it into your function, it does not exist. It's not equal to 0. So this would be my solution to this inequality. Again, I think these problems are really good to practice because we're going to come back to them in a few weeks or so when we get to chapter 4. And this process, hopefully when you get to it, you'll say, oh yeah, I kind of remember when we did this. This should help us kind of remember this process when we come and revisit it in a few chapters.